Tonight, we're going somewhere quiet. A university building in Ohio, in the middle of August 1977. It's late. Most people have gone home. The hallways are the kind of empty that only happens after 9 o'clock in a building full of offices, that particular stillness where the fluorescent light seems slightly too bright for how few people are left. Outside, it's a Tuesday in summer. Somewhere across campus, somebody's radio is playing something soft. The air is warm and a little thick with that late summer heaviness, the kind that makes you feel like the whole world is half asleep. A man named Jerry Emmon is sitting at a desk, going through a stack of computer printouts that look like nothing. Numbers and letters, page after page. Column after column of data that most people would glance at and put down. He's been doing this for a while. It's ordinary work. Quiet work. The kind of work you do because you believe in something bigger than the task itself. And then he sees it. Before we go any further, if you enjoy this kind of thing, stories about the edges of human knowledge, about the moments when the universe does something strange and we're left standing there with our mouths open, please do consider subscribing. It means more than you know, and it genuinely helps this channel keep going. A like as well if the mood takes you. And if you suggested this topic, if you left a comment somewhere saying, do the wow signal, thank you. This one's for you, and I hope it's everything you hoped it would be. Drop a comment tonight if you feel like it. Tell me where you are. Tell me what time it is. Tell me if you're in bed with the lights already off or if you're somewhere else entirely. I love reading those. And if you're listening on Spotify tonight rather than watching, welcome. Make yourself comfortable. We're going to be here a while. Turn off the lights. Pull the blanket up. Settle in. Maybe open a window if the night is cool enough. It's a good night to think about the sky. Find that spot where you're not quite sitting up and not quite lying down, that perfect in-between place where the world starts to go a little soft at the edges. And try not to think too hard about what it would mean if, somewhere out there in the dark, something was trying to reach us. Try not to think about it too hard. We'll do that together, slowly, and by the end of tonight you'll either fall asleep with a great sense of wonder, or you'll be lying there at 2 in the morning staring at the ceiling. Possibly both. Probably both. Either way, welcome to the still hour. Let me ask you something before we begin. What would it mean, really mean, in your bones at 3 in the morning when the room is dark and quiet? What would it actually mean if we weren't alone? Not as an abstract idea, not as a science fiction premise, but as a real fact, a confirmed thing, something that somebody had written a paper about and presented at a conference and the world had said, yes, we accept this is true. What would that do to the way you looked at the sky? What would it do to everything? And here's the thing that keeps the scientists up at night, the thing that crawls around the edges of this story and never quite goes away. Why did the signal never come back? If something out there sent a message, and we'll get to whether it did, don't worry, we'll sit with all of that very carefully. Why only once? Why 72 seconds and then silence forever? Did they send it and we weren't listening at the right moment, and they've been broadcasting ever since into what they think is an empty universe? Or did they send it just once, deliberately, and they're waiting for a reply that they'll never get because we didn't know what to do? Was it a natural phenomenon we simply don't understand yet? Some quirk of physics, some exotic astronomical event that produces a signal that looks, with almost mocking precision, exactly like what a radio transmission from an intelligent civilization would look like? Was it a satellite tumbling through orbit? Some forgotten piece of Cold War hardware bouncing a signal back at us from the wrong angle? Was it a comet? There's a theory, we'll get to it. It's not a very satisfying theory. Was it something we've already explained and just not accepted yet? Or was it something else entirely? If an alien civilization was advanced enough to send a signal across interstellar space, why only once? Why no follow-up? Why no coordinates, no repetition, no pattern that we could lock onto and say, yes, here is where this came from, here is what this means? Did they give up on us? Did they decide, 72 seconds in, that this particular corner of the galaxy wasn't worth the effort? Or, and I find this the most quietly devastating possibility of all, did they send that signal thousands of years ago or millions of years ago, and whatever they were is long gone now, and that 72-second burst of something is all that's left of them, a message in a bottle from a civilization that no longer exists, drifting across the dark? These are the questions. We are going to live with them tonight. They don't all have answers. Some of them don't have anything close to an answer. And I think that's exactly what makes this story worth telling slowly, in the dark, when the world is quiet enough to let you really feel the weight of them. August 15, 1977. Ohio State University, Delaware, Ohio. On the edge of campus, occupying a stretch of flat Ohio land that might otherwise have been a parking lot or a sports field, sits one of the most remarkable pieces of scientific equipment in the United States. It's called Big Ear, and if you saw it from a distance, you might think it was some kind of enormous agricultural structure, something for storing grain, maybe, or a very large and very flat greenhouse. It doesn't look like what most people imagine when they picture a radio telescope. There's no enormous dish pointing at the sky, no gleaming parabolic curve. Big Ear is different. It lies flat on the ground like a football field made of metal, 3 football fields, actually, laid end to end, covered in a mesh of wire and aluminium that reflects radio waves up toward a tilted reflector at one end. It is, in the simplest terms, a giant ear pressed to the ground, listening to the sky as the Earth slowly rotates beneath it. It can't be pointed. It doesn't move. It simply waits and lets the rotation of the planet sweep the sky across its field of vision, one narrow strip at a time. It had been running its SETI survey, its search for extraterrestrial intelligence, since 1973. Every day it scanned. Every day it printed its findings on long rolls of paper. And every day somebody had to sit down and go through those rolls, column by column, number by number, looking for something that didn't belong. Nobody monitored it in real time. The data was printed and reviewed later, which is how something extraordinary almost went unnoticed. To understand why that moment in Ohio mattered, why one circled sequence of characters on a computer printout became one of the most discussed pieces of paper in the history of science, you have to go back a little further. You have to understand the world that produced Big Ear and the question that Big Ear was built to answer. The late 1970s were a strange, in-between kind of time for space exploration. The space race, that extraordinary, slightly mad sprint between the United States and the Soviet Union to see who could do the most impossible things above the atmosphere, was winding down. Apollo was over. The last astronauts had left the moon in December 1972, and nobody had been back since, and increasingly it looked like nobody would be going back anytime soon. The budgets had tightened. The political urgency had faded. The technology that had sent human beings to the surface of another world was sitting in museums, or in warehouses, or in the memories of the people who'd built it and flown it and watched it from the ground. But the question that the space race had raised, that gorgeous, vertiginous question that you get when you spend enough time looking at the sky and really thinking about what's out there, that question was very much alive. Are we alone? This is one of those questions that sounds simple and is, in fact, one of the most profound things a human being can ask. It touches everything. It touches biology and physics and philosophy and theology and the quiet, private sense most of us have, late at night, that the universe is too large and too strange for us to be the only ones in it who are aware of it. When you lie outside on a clear night and look up at the Milky Way and really sit with the scale of what you're seeing, hundreds of billions of stars, each one a sun, many of them with planets orbiting them, and that's just our galaxy, one galaxy among hundreds of billions of galaxies, it's very hard to believe that in all of that extraordinary vastness, the only place where anything ever looked up and wondered about it was here. This small blue planet. This Tuesday in August in Ohio. And yet we didn't know. We still don't know. The universe is under no obligation to arrange itself according to what feels right to us when we're lying on our backs in the dark. By 1977, the scientific community had been wrestling seriously with this question for almost 2 decades. The person most responsible for turning "Are We Alone?" from a philosophical musing into an actual scientific program was a young astronomer named Frank Drake. In 1960, at the National Radio Astronomy Observatory in Green Bank, West Virginia, Drake pointed a radio telescope at 2 nearby sun-like stars, Tau Ceti and Epsilon Eridani, and listened. This was Project Ozma, named for the Queen of Oz, and it was the first deliberate, systematic attempt by human beings to detect radio signals from another civilization. Drake listened for several months. He heard nothing. Or rather, he heard one signal that briefly got everyone extremely excited before being traced back to a secret military aircraft. Which, depending on your perspective, is either a hilarious anticlimax or a preview of things to come. But Project Ozma had done something important. It had demonstrated that this was a thing you could actually do. You could sit down with a radio telescope and point it at the sky and listen for signals from other civilizations. It wasn't fantasy. It was science. It had a methodology and a testable hypothesis, and you could write papers about it and present it at conferences, and other serious people would engage with it seriously. And then Drake did something else that cemented SETI, the search for extraterrestrial intelligence, as the field came to be known, as a genuine scientific discipline. In 1961, he organized a small conference at Green Bank, a gathering of some of the sharpest minds in astronomy, biology, chemistry, and related fields, to think collectively about this question. And to open that conference, he wrote an equation on a blackboard. You've probably heard of the Drake equation, even if you don't know all the details. It's a formula, though formula makes it sound more precise than it is, for estimating how many communicating civilizations might exist in the Milky Way at any given time. It takes into account the rate at which stars form, the fraction of those stars that have planets, the fraction of those planets that could support life, the fraction where life actually develops, the fraction where intelligence develops, the fraction where that intelligence develops technology that broadcasts signals into space, and the length of time such civilizations survive and continue broadcasting. Multiply all those fractions together and you get a number. The Drake equation. The extraordinary thing about the Drake equation is not that it gives you an answer. It doesn't really. The uncertainties in those fractions are enormous, and the estimates people plug in vary wildly depending on their assumptions. The extraordinary thing is that it frames the question. It says, here are the variables. Here is the shape of what we're trying to figure out. It turns the question, are we alone? From something you can only shrug at into something you can actually work on, piece by piece, as our knowledge of astronomy and biology improves. By the late 1970s, our knowledge of some of those pieces had improved considerably. The discovery of exoplanets was still years away, but astronomers were increasingly confident that planetary systems were common around stars. The chemical building blocks of life had been found in meteorites and in interstellar space. The picture was looking, tentatively, carefully, like life might not be impossibly rare. And running underneath all of this was an assumption, a beautiful, hopeful, deeply human assumption about the frequency. If an intelligent civilization somewhere in the galaxy wanted to broadcast a signal that another intelligent civilization could find, what frequency would they use? The answer, most SETI scientists agreed, was 1,420 megahertz. This is the frequency at which hydrogen naturally emits radio waves. Hydrogen being the most abundant element in the universe, hydrogen being the element that any technologically advanced civilization would have studied early in their scientific development, hydrogen being the universal signpost. If you want to put up a cosmic billboard that says, "Someone lives here," you broadcast near the hydrogen line. It's the frequency that any civilization with a radio telescope would already be monitoring. It's the cosmic hello frequency. And Big Ear, in Delaware, Ohio, was listening to it. This was a beautiful idea. I mean that genuinely. There is something almost unbearably hopeful about the image of human beings in the mid-20th century, in the middle of all the Cold War anxiety and the arms race and the daily business of being alive on a complicated planet, sitting down and saying, "Let's listen. Let's build enormous machines and point them at the sky and listen carefully and systematically in case somebody out there is trying to say hello." It's one of the most optimistic things our species has ever done. Not because it worked, we'll get to that, but because of the quality of the hope it represents. The belief that we are not alone, and that whoever else is out there is also curious, also interested in reaching beyond themselves, also sending something out into the dark in the hope that something will hear it. Scientists were genuinely listening for someone to say hello. And on August 15th, 1977, something said something. I want to tell you about Big Ear properly, because it deserves it. When most people picture a radio telescope, they picture something like the Arecibo dish, that enormous bowl cut into the limestone hills of Puerto Rico, 300 meters across, pointing at the sky like an open hand. Or they picture the very large array in New Mexico, those 27 gleaming white dishes arranged in a Y shape across the desert, each one swiveling on its rails to track different parts of the sky. These are the iconic images. These are the things that appear in science documentaries and in science fiction films when somebody needs to establish that we are, as a civilization, listening for something. Big Ear looked nothing like this. Big Ear was built in the early 1960s at Ohio State University on a flat stretch of land in Delaware, Ohio, about 20 miles north of Columbus. It was the brainchild of John Krause, an antenna engineer and radio astronomer who had a gift for building large, functional things on limited budgets. The design he chose was what's called a Krause-type transit telescope, a flat telescope lying on the ground, using the rotation of the Earth to scan the sky rather than moving itself. No dish, no swiveling components, just a massive flat reflector about 100 meters wide and 200 meters long, tilted slightly toward the south, and at one end a large curved reflector that focused the incoming radio waves onto a feed horn where they could be detected and measured. From above, it looked something like an enormous table, or, perhaps more poetically, like someone had taken a football stadium and removed everything except the playing field, then covered it in wire mesh and tilted one end slightly upward. It was not beautiful in the conventional sense. It was functional, workmanlike, built for purpose. But there was something quietly magnificent about it, this enormous flat ear, lying there in the Ohio countryside, patient and still, listening to the universe go by overhead. It worked by doing nothing. Or rather, it worked by doing one thing and doing it continuously, without interruption, without fatigue, without the human tendency to get bored and look away. The Earth rotated. Big Ear stayed still. And as the Earth turned, different strips of sky swept slowly across Big Ear's field of view, each strip roughly 2 arc-minutes wide, about 1/15 the width of the full moon, held in focus for exactly 72 seconds before the rotation of the Earth carried it past. 72 seconds. Remember that number. Big Ear had been running its SETI survey since 1973 under the Ohio SETI program. Every day it scanned. Every day the data was fed into a computer, the IBM 1130 that processed the signals and converted them into a printout format, and every day those printouts accumulated rolls of paper dense with numbers and letters that represented the intensity of radio signals coming from different parts of the sky. The scale used was a number-then-letter system, roughly like this. Blank spaces and low numbers represented weak signals, ordinary background noise, nothing unusual. The letters came in as signals got stronger, B, C, and so on, up through the alphabet, with you representing the strongest signals the system could comfortably express. And somebody had to go through all of this data, by hand, column by column. This was where the volunteers came in. Jerry Emmon was not a full-time employee of Ohio State University's radio astronomy program. He had been, at one point, he'd been a faculty member in the electrical engineering and astronomy departments, but by 1977, he was working elsewhere. He came to Big Ear as a volunteer, giving his evenings and weekends to the work of analyzing the data that the telescope produced in quantities that the small paid staff couldn't get through on their own. He was one of several such volunteers, people who found meaning in the patient, largely unrewarding work of going through columns of numbers looking for something that, statistically speaking, you would almost certainly never find. Think about what that patience means. Think about what it takes to do something like that. You sit down with a roll of paper and you go through it, and every day, every single day for years, the data says nothing. Noise, background radiation, natural sources, the hiss and crackle of a universe going about its own business without any apparent interest in communicating. You go through column after column of ordinary numbers, and nothing is there, and you come back the next day and do it again. You believe on some level, you have to believe, otherwise why are you doing this, that somewhere in all of those ordinary numbers, one day, something extraordinary is going to appear. And you keep looking. There is something melancholy about this, and something beautiful. It's the melancholy and beauty of the long bet, the patient hope. It's the quality of commitment that most of us, in our private moments, wish we had for something. To believe so thoroughly in the possibility of something that you will sit with the absence of it, day after day, and not give up. These were the people who were listening. Not the famous scientists, most of the time, not the people whose names end up in textbooks. The people doing the actual work of listening were volunteers. People who loved the idea of what this telescope was doing, who found meaning in the possibility even when the probability seemed vanishingly small, who showed up and put in the hours because someone had to. Jerry Emin was one of them. And in late August of 1977, somebody handed him a stack of printouts. Here is what happened, as best we can reconstruct it. On the night of August 15, 1977, Big Ear was doing what it always did. Lying there in the Ohio countryside, still and patient, letting the sky drift overhead. It was a Tuesday. Nobody was watching it happen in real time. The telescope scanned, the computer processed, the printer printed, and the paper accumulated in its tray, and that was all. The region of sky that swept across Big Ear's field of view during that particular night, or rather, during one particular 72-second window within that night, was a patch of sky in the constellation Sagittarius. Sagittarius, the Archer. A summer constellation, rich in stars, lying roughly in the direction of the center of the Milky Way. It's a busy part of the sky, full of star clusters and nebulae and the crowded stellar landscape of the galactic bulge. And in that particular patch of Sagittarius, in that particular 72-second window, Big Ear detected something. The computer processed it. The printer printed it. The paper moved on. And the signal, whatever it was, wherever it came from, swept past Big Ear's field of view and was gone. The printout sat in a tray. Nobody looked at it that night. Nobody knew. Days passed. The data accumulated as it always did, and eventually it was bundled up and handed to the volunteers. And at some point in late August, the exact date isn't recorded, which is somehow very fitting for this story, the most significant moment in the history of SETI arrived without anyone marking it down. Jerry Emin took a stack of printouts home and sat down at his kitchen table to go through them. Picture this moment. Sit with it for a second. A kitchen table. A stack of paper. A red pen. Maybe a cup of coffee. Outside, it's late summer in Ohio, that heavy, golden time of year when the light goes orange in the late afternoon and the insects are very loud at night and the air smells like cut grass and earth. Jerry Emin is not expecting to find anything. Nobody ever expects to find anything. He has done this dozens of times, hundreds of times, going through columns of ordinary numbers looking for extraordinary ones. He has never found anything. He goes down the columns. Numbers and letters. Background noise. Nothing, nothing, nothing. And then, the sequence he saw was this: 6EQUJ5. 6 characters, printed in a column, 1 in each row, representing 6 consecutive measurements as that particular strip of sky swept across Big Ear's field of view. And those 6 characters told a story if you knew how to read it. The numbers 6, 5 represented signal intensities 6 and 5 times above background noise. Unusual, but not extraordinary. But the letters in between, Q, He, those were a different matter. Remember the scale. The letters represented stronger and stronger signals, ascending through the alphabet. E was a strong signal. Q was a very strong signal. U was the strongest value the system comfortably represented, a signal 30 times above background noise, which was frankly so far above anything the system typically detected that U was essentially the top of the scale. The signal had come from nothing. It had risen through E, through Q, to U, to 30 times background noise, and then fallen back through J, through 5, to nothing again, in exactly 6 data points, which was exactly the number of data points you would expect if a signal came from a fixed point in space as the Earth's rotation carried it through Big Ear's 72-second field of view. Jerry Emmon looked at those 6 characters. He understood immediately what he was looking at. He reached for his red pen. He circled it, and in the margin, next to the circle, he wrote one word. Just that. One word with an exclamation point. The most understated expression of one of the most significant moments in human scientific history. He didn't write possible alien signal. He didn't write extraordinary discovery. He wrote what a person writes when they see something so remarkable and so unexpected that all the formal language falls away and what's left is pure, unmediated reaction. He wrote what you'd write if you were reading a novel and the plot suddenly did something so perfect and so surprising that you forgot you were reading and just said the word out loud to an empty room. But he saw that the signal was broadcasting on 1420 megahertz, the hydrogen line. The frequency that SETI scientists had said for years was the one to watch. The frequency that any technologically advanced civilization would use if they wanted to be found. He saw that the signal lasted exactly 72 seconds, exactly the duration of Big Ear's detection window, exactly the duration you'd expect from a signal coming from a fixed point in space. He saw that the intensity profile, the way it rose and fell, matched, with remarkable precision, the bell curve pattern that a true extraterrestrial signal would produce as the Earth's rotation carried it through the telescope's field of view. Everything was right. Everything was exactly right. Jerry Emmons sat at his kitchen table in Ohio on a late summer afternoon and looked at 6 characters circled in red pen and understood that he might be looking at the first confirmed message from another civilization in the history of the human race. The stillness of that moment is extraordinary to think about. The ordinariness of it. A kitchen table. A red pen. The Ohio summer outside the window. The universe, indifferent and vast, going about its incomprehensible business. And on a piece of paper, in a column of data, 6 characters that might mean everything, or might mean something else entirely. But that question would come later. In the moment, in the quiet of that kitchen, on that ordinary afternoon, what there was just the signal, and a man who knew what he was looking at, and a red pen, and one word that said more than any formal language could. But let me walk you through what made that signal so remarkable. Not just as a matter of record, but because I think when you understand the technical details, when you really sit with what Big Ear detected and why it was so strange, the whole thing becomes even more extraordinary, not less. The printout code was 6EQUJ5. 6 data points, 1 printed per row, each row representing a 12-second interval as Big Ear's 72-second detection window swept that patch of sky. The intensity scale the Ohio State program used was based on standard deviations above background noise. The numbers 1 through 9 represented intensities 1 through 9 times above background. Then the system switched to letters, with A representing 10 times above background, B 11, C 12, and so on. The letter U, which appeared at the peak of that sequence, represented 30 times above background noise. 30 times. To put that in context, most of the signals Big Ear detected during its routine scanning were barely distinguishable from background noise. Occasionally you'd see a 2 or a 3. Strong radio sources, known astronomical objects, pulsars, quasars, might produce higher readings, but they were cataloged, understood, accounted for. They'd been seen before. They had explanations. Wow. Signal's peak intensity of 30 times above background noise had never been seen in Big Ear's data before. Not once, in 4 years of continuous scanning, had anything like this appeared. But the intensity alone, remarkable as it was, wasn't what made the signal so significant. What made it significant was the combination of factors, the way everything about it lined up with what you'd predict for a genuine extraterrestrial transmission. First, the frequency, 1420.4556 MHz. The hydrogen line, as close to the center of that frequency as the measurement allowed. SETI scientists had been saying for years that this was the frequency to watch. The hydrogen line is a universal reference point. It's the radio frequency that hydrogen atoms naturally emit as electrons make a particular quantum transition, and it's the most common radio emission in the universe. It's been called the cosmic watering hole, because it's the frequency where different civilizations, if they exist, might naturally gather to listen and to broadcast, the way animals in a desert gather at the only water source available. You broadcast near the hydrogen line because any civilization with radio telescopes will already be monitoring that frequency. If you want to be heard, that's where you speak. Wow. Signal was speaking exactly there. Second, the polarization. The signal appeared to be narrowband, concentrated in a very narrow slice of the frequency spectrum. This is significant because natural radio sources, stars, gas clouds, pulsars, tend to broadcast across a wide range of frequencies simultaneously. A narrowband signal, concentrated at one specific frequency, is much more characteristic of a deliberate transmission. It's the difference between a bonfire and a laser pointer. Nature tends toward bonfires. Technology tends toward laser pointers. Third, the pattern. The way the signal's intensity rose and fell over those 72 seconds, rising from nothing, peaking at you, falling back to nothing, matched with almost uncanny precision the theoretical profile of a signal coming from a fixed point in space. Big Ear, remember, didn't move. The sky moved past it as the Earth rotated. If you have a source in a fixed position in the sky, its signal will enter Big Ear's beam, grow stronger as it approaches the center of the beam, peak at the center, and then fade as the rotation of the Earth carries it out the other side. That's a bell curve, roughly symmetrical. And that's exactly what 6EQUJ5 showed. The signal knew, if you'll forgive the poetic leap, how Big Ear worked. It behaved exactly the way a real signal from a fixed point in the sky was supposed to behave. And then there was the direction. The signal came from a patch of sky in the constellation Sagittarius, specifically from a region between the stars Chi Sagittarii and the globular cluster M55, depending on which of Big Ear's two horns first detected it. Big Ear had 2 feed horns, separated by a few arc minutes, and the signal appeared in only one of them, which is another small strange detail we'll come back to. That region of Sagittarius is, to the best of our astronomical knowledge, empty in the relevant sense. There are no stars close enough, within a few hundred light years, that would be obvious candidates for a civilization capable of broadcasting a signal strong enough to register at 30 times above background noise on a relatively modest radio telescope in Ohio. This is either a problem or a clue, depending on how you think about it. Either the signal came from much farther away than we'd expect, from a civilization so advanced that they can broadcast with extraordinary power across enormous distances, or it came from somewhere we haven't fully mapped, or it came from somewhere in our own solar system and wasn't extraterrestrial at all. Each of these options has its own complications. And then it stopped. That's the thing that sits at the center of this story and won't leave. The signal lasted 72 seconds, exactly as long as Big Ear's detection window, and then it was gone. Big Ear swept back to that part of the sky the next day. Nothing. And the day after that. Nothing. And the week after that, and the month after that, and the year after that. Silence. Total, unbroken silence from that patch of sky in Sagittarius. It's very hard to explain. If the signal was a natural phenomenon, a known astronomical source, a fluke of the telescope's equipment, a stray signal from a human-made satellite, you'd expect to be able to reproduce it, or at least to find an explanation that covers all the details. And nobody has. Not the frequency, not the intensity, not the pattern, not the duration, not the direction. All of it together, bundled into those 6 characters on a piece of printout paper, constitutes something that is simultaneously the most promising and the most frustrating piece of data in the history of SETI. Completely clear, in the sense that what it shows is unambiguous. The signal is there. The numbers don't lie. Completely inexplicable, in the sense that nobody has ever satisfactorily explained what it was. Which, if you think about it, is either wonderful or terrifying. It's wonderful because it means the mystery is still real, still alive, still unresolved. The universe hasn't closed this door, hasn't told us it was nothing, has left the question hanging in the air for 47 years. It's terrifying for exactly the same reason. When word of the wow signal got out, and it did get out, gradually, cautiously, the way significant things move through the scientific community before they move through everything else, the response was what you might expect from a community of people who are professionally trained to be skeptical of extraordinary claims. Excitement, yes, but measured excitement, cautious excitement, the kind of excitement that immediately starts looking for reasons to talk itself back down. Jerry Emmon himself was cautious. This is worth saying clearly. The man who wrote, "Wow," in the margin was not someone who immediately ran to the press and announced contact with alien civilization. He was a scientist. He knew, better than almost anyone, what the signal meant and what it didn't mean. It meant that Big Ear had detected something extraordinary. It couldn't, on the basis of a single detection, mean that we had received a message from another civilization. Science doesn't work that way. One data point is not confirmation. One data point, however extraordinary, is the beginning of a question, not the answer to it. The first step was straightforward. Try to detect it again. Big Ear pointed at the same coordinates in Sagittarius the very next day. Nothing. The day after that. Nothing. John Krause and Bob Dixon, the directors of the Ohio SETI program, were notified. They reviewed the data. They agreed that the signal was extraordinary and unexplained. They began a systematic campaign of follow-up observations, pointing Big Ear at those coordinates over and over again, waiting for the signal to repeat. In the months following the initial detection, Big Ear looked at that patch of sky more than 50 times. Then 100 times. Then more. Silence. News of the signal reached the broader SETI community, and other telescopes joined the search. Observatories in the United States and elsewhere turned their instruments toward that corner of Sagittarius and listened. In 1977 and into 1978, there were coordinated efforts. Multiple telescopes, different frequencies, different sensitivities, all pointed at the same patch of sky, all listening for anything. Major radio telescopes, including some that were significantly more sensitive than Big Ear, were brought to bear on the problem. They heard nothing. The wow signal has never been detected again. Not once, in 47 years of searching. Not by Big Ear, which continued operating until 1997, when the university sold the land it sat on to a golf course developer. And that is where the story gets interesting. Because now comes the part where everyone, scientists, theorists, dreamers, skeptics, has something to say. The signal sat there in the archive, circled in red, and the world's most careful minds began doing what careful minds do when they encounter something they cannot explain. They started building theories. And each theory is its own kind of story, some of them hopeful, some of them deflating, all of them honest attempts to make sense of 72 seconds that refuse to make sense on their own. So let's go through them together, slowly, the way you'd go through them at midnight with someone you trusted. With warmth and no particular rush, and the full understanding that the most interesting thing about each theory is not necessarily whether it's right. Let's start with the obvious one. The one you've been thinking about since part 1. Theory 1. Extraterrestrial intelligence. Here is the uncomfortable truth about this theory. It fits. It doesn't just loosely, vaguely, poetically fit in the way that conspiracy theories fit, where you squint and rearrange and decide the gaps are actually evidence. It fits the way a key fits a lock. Clinically, specifically, almost suspiciously well. Think about it this way. If you were a SETI scientist in 1977 and someone asked you to describe, in advance, what a signal from an extraterrestrial civilization might look like, what would you say? You'd say it would probably come from deep space, not from Earth or nearby solar objects, because you're looking for something beyond our neighborhood. You'd say it would probably be transmitted at or near 1,420 megahertz, because that's the hydrogen line, the universal constant, the frequency that any technologically capable civilization would recognize as the cosmic meeting point. You'd say it would probably be narrowband, concentrated at one frequency rather than scattered across many, because that's how you distinguish an intentional signal from background noise. You'd say it would probably be significantly stronger than the ambient noise of space, strong enough to stand out unmistakably. And you'd say it would probably appear to come from a fixed point in the sky, moving with the stars rather than with Earth, which is how you'd confirm it was genuinely astronomical rather than terrestrial. The wow signal checked every single one of those boxes. Every one. And that is the thing that keeps serious scientists up at night even now, almost 50 years later. This wasn't a vague anomaly that enthusiasts decided to interpret as alien. This was a signal that matched the theoretical predictions of extraterrestrial contact with an almost unsettling precision. Jerry Emin, who was not a dramatic man, who was not a credulous man, who spent decades being careful with his language around this, even he acknowledged that if you had asked him what ET contact would look like, the wow signal would have been his answer. And then comes the part where the story gets hard. It was never detected again. Not once. Not a hint. Not a partial reading. Not an echo. Not a statistical ghost. Dozens of follow-up observations pointed Big Ear and other radio telescopes at that same patch of sky in the constellation Sagittarius, and they got what the universe usually gives: silence. The signal appeared, fully formed, stronger than almost anything ever received, matching every theoretical criterion for intelligent extraterrestrial contact, and then it left, and it never came back. Which is a problem if you're a scientist. Science requires repeatability. One data point isn't a discovery, it's an observation. You need to be able to look at the same thing twice, have other people look at it, build a pattern. The wow signal is exactly one data point. One extraordinary, inexplicable, criteria-matching data point, sitting there alone in the archive, refusing to become two. And so the theory that the WOW signal was a transmission from an intelligent extraterrestrial civilization remains simultaneously the most compelling theory anyone has proposed and the least provable. It might be the most important thing any human being has ever found. It might also, and this is the brutal honesty of science, be a coincidence so profound it fooled us. We don't know. We genuinely, truly, honestly do not know. And sitting with that right now in the quiet, there's something both terrible and wonderful about it. Theory 2, natural astrophysical phenomena. The universe, you should know, does not need our help to be extraordinary. It generates its own wonders at a scale we can barely imagine. Pulsars, collapsed stellar remnants spinning hundreds of times per second, sweeping beams of radio energy across the cosmos like lighthouses in the dark. Magnetars, neutron stars with magnetic fields so intense they would strip the iron from your blood at a range of 1,000 miles. Fast radio bursts, millisecond flashes of radio energy from billions of light years away, some of them repeating, most of them still unexplained. The universe is loud and strange, and it produces radio signals that would have seemed like science fiction 50 years ago. So the reasonable question is, could one of those natural phenomena explain the WOW signal? The problem is that when you actually sit down and go through the known catalog of natural radio sources and match them against the specific characteristics of the signal, nothing quite fits. No known natural phenomenon produces a narrowband signal at almost exactly 1,420 MHz with the specific intensity pattern and duration of the WOW signal from that particular region of sky. Pulsars produce broadband signals and they repeat with extraordinary regularity. They're basically cosmic clocks, and the WOW signal showed none of that repeating structure. Magnetars are broadband. Fast radio bursts, while still mysterious, have different frequency and duration profiles. The signal's hydrogen line frequency, in particular, is strange for a natural source, not impossible in principle, but unexplained in practice. There's a phrase scientists sometimes use: the universe is stranger than we can suppose. And that's true. It's entirely possible that some exotic natural phenomenon we haven't yet characterized could produce exactly the signal Big Ear received. The universe has surprised us before and will surprise us again. But right now, with what we know, the natural explanation requires us to invoke something we don't yet have evidence for, which is less comfortable than it sounds, because it means we're explaining one mystery with another mystery. And while that's sometimes necessary in science, it's not exactly satisfying. The universe is strange, but it rarely arranges itself this conveniently, this specifically, as if answering a question we've been asking. Theory 3, the comet hypothesis. I want to tell you about this theory with particular gentleness, because it's the one that got the most hope attached to it, and the one that most comprehensively failed to deliver on that hope. In 2017, astronomer Antonio Paris published a paper proposing that the WOW signal had a perfectly mundane natural explanation. Two comets, 266P/Christensen and 335P/Gibbs, had been passing through the region of sky from which the signal appeared to originate in August 1977, and comets, Paris argued, are surrounded by clouds of hydrogen gas that could theoretically emit radio signals at 1,420 MHz. The signal wasn't aliens, he suggested. It wasn't a cosmic mystery. It was just a comet, briefly loud, now gone. You can imagine the news coverage. Of course you can. Mystery solved. Wow. Signal was likely a comet. Headlines across the world. Social media posts. A 40-year enigma finally explained, tidally, naturally, by a passing rock and some hydrogen gas. And for a moment, just a moment, it felt like relief. The kind of relief you feel when you've been living with a question for a long time and someone finally gives you an answer. Even if the answer is smaller and less magical than what you were hoping for, there's something peaceful about resolution. Except it didn't hold. Multiple scientists went over Paris's methodology and found serious problems. The intensity of hydrogen emission from a comet, several researchers pointed out, is simply not strong enough to produce a signal of the magnitude Big Ear received. The numbers didn't work. Antonio Paris had made his calculations using parameters that other researchers couldn't replicate or validate. The signal-to-noise ratio alone should have disqualified the comet hypothesis, the WOW. Signal was dramatically, conspicuously louder than comet hydrogen emission could account for. And then there was Jerry Emin himself, who had spent decades being careful, being measured, refusing to overclaim. Emin reviewed the comet hypothesis and rejected it publicly. He laid out specific technical reasons why the numbers didn't add up, why the comet's position wasn't cleanly consistent with the signal's apparent source coordinates, why the explanation created more problems than it solved. The comet hypothesis had the great misfortune of being simultaneously exciting enough to generate enormous coverage and flawed enough to fail under expert scrutiny. It was the story the world wanted, the simple natural explanation, the mystery wrapped up, the question answered. And the universe, once again, declined to give us the easy answer. It left the WOW signal where it has always been, in the category of things we found once and do not understand. That's the particular sadness of the comet theory. It promised resolution, and then it didn't deliver. And the unanswered question came back, a little lonelier than before. Theory 4, Earth-based interference. This is the theory that feels most sensible to a certain kind of mind, the one that defaults to the simplest possible explanation and works outward from there. What if the WOW signal wasn't from space at all? What if it was a satellite or a military radar, or some classified transmission, or a reflection of an Earth signal bouncing off a piece of debris in orbit? What if Big Ear was just picking up something human? It's a reasonable place to start. Radio frequency interference was a real problem for SETI researchers in the 1970s and remains a real problem now. The electromagnetic spectrum around Earth is busy and getting busier, and radio telescopes have to work hard to filter out terrestrial contamination. But here is where the WOW signal becomes stubborn again. The signal's characteristics strongly indicate a source beyond Earth's orbit. The way it rose and fell over those 72 seconds is consistent with a fixed astronomical source passing through Big Ear's beam as the Earth rotated, which is exactly how genuine deep space signals behave and not how satellites or terrestrial interference behave. Satellites move against the stellar background in a way that produces a different kind of signature. The WOW signal behaved like something that wasn't moving relative to the stars, which places it, by definition, far away. And then there's the frequency. 1420 MHz was protected. By international agreement at the time, that frequency was reserved for radio astronomy precisely because it was the hydrogen line, the scientific sacred ground. Terrestrial transmissions weren't supposed to be there, which doesn't mean they couldn't have been. Classified military operations don't necessarily follow international radio agreements, but if it was a classified transmission, it was one that happened to perfectly mimic the expected behavior of a deep space astronomical source at the most symbolically significant frequency in the spectrum, which seems, if you'll forgive the word, unlikely. Theory 5. We simply don't know. And this is the theory that Jerry Emin ultimately arrived at after more than 4 decades of thinking about it. Not aliens, not a comet, not terrestrial interference, not a known natural phenomenon. Just the most interesting candidate signal ever detected, source unknown. I want to sit with that for a moment because it deserves more than a paragraph. It is extraordinarily hard, in science and in life, to say, I don't know, about something you want to have an answer to. The human mind is not comfortable with unresolved questions. We tell ourselves stories to fill the gaps. It's how we're built. It's why religion and mythology and conspiracy theories exist. The gap between something happened and I understand what happened is deeply uncomfortable, and we will do almost anything to fill it, including accepting bad explanations because they're better than no explanation at all. Jerry Emmon looked at the most extraordinary thing he ever found, worked on it for decades, and said, I cannot claim to know what this was. I believe it was the best SETI candidate ever detected. I cannot tell you it was extraterrestrial. I cannot tell you it wasn't. I don't know. That kind of intellectual honesty is genuinely rare. In a world full of people who overclaim, who attach certainty to uncertainty, who mistake hoping for knowing, the quiet determination to say, I don't know, and mean it is almost a form of courage. It's the hardest thing to say when you want something to be true. It might also be the most important thing a scientist can say. The wow. Signal, after all this time, after all the theories and the rebuttals and the media cycles and the follow-up searches, remains exactly what it was in 1977, something that happened once that we cannot explain. And there is something almost beautiful in that. Let's talk about the man who wrote the word. Jerry Emmon was not famous. He was not a celebrated figure in the SETI community the way Frank Drake was, who designed the experiment, or Carl Sagan was, who made it matter to the public. He was a volunteer researcher, a college professor who believed in the project enough to spend his evenings going through printouts when he could have been doing something else. He wasn't even at the telescope when it happened. That's the thing people sometimes forget. The telescope was automated. The data came in on fanfold paper. And several days later, Emmon sat down at a kitchen table with that printout and went through it, column by column, row by row, in the particular quiet way of a man who has done this many times before without finding anything. Think about what that life was like. The SETI program at Ohio State in the 1970s was not glamorous. It was not well funded. It existed in the particular twilight zone of science that was considered slightly embarrassing by mainstream astronomy, serious enough to be worth doing, not serious enough for a proper budget. The people who worked on it were doing so partly on faith. You listened because the alternative was not listening. You showed up because someone had to. You went through the printouts because if you didn't, nobody would, and somewhere in all that silence might be something that mattered. Most nights, there was nothing. The printouts were full of noise and background radiation and the occasional burst of terrestrial interference, and you noted it all and you moved on. The work was patient and repetitive and unglamorous, and the people who did it kept doing it because they believed in the question even when the question wasn't answering back. And then one evening in August 1977, the question answered back. Can you imagine that moment? You're a college professor at home, going through a printout. You're not expecting anything because you never expect anything. You've learned not to expect anything. And then you see a sequence of numbers that doesn't match the noise, that rises, peaks, and falls in exactly the pattern you'd theoretically expect from a real deep space signal. And you sit there for a moment, and you understand, in the quiet of a suburban Ohio home, that you might be looking at the most important thing any human being has ever found. And you circle it, and you write one word. But not a press release, not a phone call to the director. One word, in the margin, with a felt-tip pen, on a piece of computer paper at a kitchen table. And in that one word there is so much, the surprise and the wonder and the very human instinct to mark the moment when something extraordinary walks into your ordinary life. But the most honest response a person could have. What happened after was stranger, in its own way. The signal didn't come back. The follow-up searches found nothing. And Jerry Emmon went back to being a college professor, except now he was the college professor who had written, wow, in the margin of the most extraordinary SETI printout in history, and for the rest of his life people would ask him about it, and he would answer carefully. He never overclaimed. That's the thing I want you to understand about him. In a world that was constantly trying to pull him toward the more exciting story, The aliens, the message, the contact, he held the line. He said it was extraordinary. He said it was unexplained. He said it was the best candidate signal set he had ever found. And he said he didn't know what it was, and he meant it, and he didn't apologize for meaning it. There's a particular kind of integrity in that. When the entire world is asking you to say the dramatic thing, and you have every emotional reason to say it, and part of you might even believe it, to still say quietly, I don't know, take something. It takes a respect for the truth that is almost old-fashioned in its sincerity. He spent more than 4 decades answering questions about 72 seconds of signal. He was careful every single time. He was honest every single time. He sat with the uncertainty and he didn't dress it up into something more comfortable. Jerry Emin passed away in 2023. He was 83 years old. He never found out what the signal was. None of us have. He carried the question with him until the end, and he never pretended he'd answered it. And that quiet faithfulness to the truth is, I think, one of the more remarkable things about this whole remarkable story. The signal was extraordinary, but so was the man who noticed it. There's something worth honoring in both. Here is a thing that humans do, and it is one of my favorite things about us. We find something enormous and unknowable, and we try to talk back to it. We don't know if anyone is there. We don't know if our messages will ever arrive. We don't know if they'd be understood if they did. We are, cosmically speaking, like someone shouting into a canyon they've never seen the bottom of. Not quite sure it's a canyon, not quite sure there's an echo, not quite sure the sound is even going in the right direction. And we do it anyway. We have always done it anyway. Because the alternative is silence, and silence feels, to a human being, like giving up. In 2012, on the 35th anniversary of the WOW signal, a group of researchers and enthusiasts did something genuinely wonderful and slightly absurd. They compiled tens of thousands of messages submitted by people on Twitter, ordinary people from all over the world, writing their own versions of what they'd want to say if anyone were listening. So, we're here. We found your signal. We haven't forgotten. They gathered these messages and they transmitted them using a Ukrainian radio telescope in the direction of the signal's origin coordinates. Into the void, toward Sagittarius, toward wherever, if anywhere, that 72-second transmission had come from. Think about that for a moment. Tens of thousands of human voices, compiled from the internet, bundled into a radio beam, aimed at an uncertain point in space 35 years after a signal arrived that we still don't understand. The scale of the gesture is enormous. The odds of it meaning anything are, frankly, not great. The travel time alone, radio waves move at the speed of light, and the signal's origin could be hundreds or thousands of light years away, means that any response, if one ever came, would arrive centuries or millennia from now. But there's something deeply, specifically human about doing it anyway. About deciding that the attempt matters even when the outcome is uncertain. About saying, to the dark, we are here too, on the off chance that something, somewhere, is listening. In 2016, a team at the Laboratoire de l'Astrophysique de Bordeaux did something different. They used a laser, a directed pulsed laser, to send a message toward the same coordinates from a telescope in Paris. The thinking here was that optical signals, photons of visible light rather than radio waves, might cut through in a different way, might be detectable by a civilization with different sensory technology than ours. It was more experimental, more speculative, but the impulse behind it was the same. We found something and we want to acknowledge it, and we will use whatever we have. And in 2020, with new generations of radio telescopes, instruments dramatically more sensitive than Big Ear had ever been, more systematic searches were conducted of the signal's origin region. The Allen Telescope Array, the FAST telescope in China, other observatories around the world have periodically returned to those coordinates, listening for something they don't know how to describe, hoping to hear something they can't predict. Nothing has come back. Not a whisper. Not a statistical hint. The sky in the direction of Sagittarius has been uniformly, patiently silent. And yet the attempts continue and will continue, and there's something I find genuinely moving about that. It would be very easy to give up. It would be rational to give up in a strict cost-benefit sense. We've had one candidate signal in 50 years of searching, and it never repeated, And every response we've sent has gone unanswered, and the whole enterprise requires an enormous amount of faith in a question that might not have an answer. But we keep pointing things at the sky. We keep compiling our Twitter messages and firing our lasers and running our search algorithms through the noise. We found one extraordinary thing once, and we have been trying to find it again ever since, and we don't even know what we're looking for, not really. We're just hoping, in the most ancient human way, pointing at the stars and hoping. There is something beautiful about that. Something that says more about us than it says about whatever might be out there. We are the species that shouts into canyons. We are the species that writes wow in the margin. We are the species that refuses to stop asking even when the universe refuses to answer. I find that worth staying awake for, even at this hour. And now the largest question. The one that was always underneath all of this. The wow. Signal was never really about in isolation, because it was always a data point in a larger inquiry that is almost too big to hold in your head at midnight. Are we alone? Let's start with the numbers, because the numbers are staggering in a way that's difficult to fully absorb. Our galaxy, the Milky Way, contains somewhere in the region of 200 to 400 billion stars. Not millions, billions. Each of those stars is a sun, and most of them, we now know, have planets. The Kepler Space Telescope and its successors have transformed our understanding of planetary prevalence in the last 2 decades. Planets are not rare. They are extraordinarily common. Some estimates suggest the average star has more than one planet, which means there are more planets in our galaxy than there are stars. The number of those planets that fall within the habitable zone, the distance from their star where liquid water can exist, is itself enormous. We're talking billions of potentially habitable worlds in just our galaxy. And our galaxy is one of roughly 2 trillion in the observable universe. 2 trillion. When you say that number out loud, it stops sounding like a number and starts sounding like something else. Like a tone. Like a pressure. Like the universe telling you something about its own scale that you don't quite have the cognitive architecture to receive. The Drake equation, developed by Frank Drake in 1961, the very year that Sirius SETI began, is a framework for estimating how many communicating civilizations might exist in our galaxy at any given time. It multiplies together a series of factors: the rate of star formation, the fraction of stars with planets, the fraction of those with potentially habitable planets, the fraction where life actually emerges, the fraction where intelligent life emerges, the fraction that developed technology, and the average lifetime of such a civilization. Drake's original estimate produced a number in the millions. Subsequent revisions, with better data on planetary formation and stellar habitable zones, have sometimes pushed the number higher. And yet, silence. 50 years of SETI. One candidate signal, 72 seconds long, never repeated. The sky is quieter than it should be if the Drake equation is right. Which brings us to the Fermi paradox, the observation attributed to physicist Enrico Fermi at a 1950 lunch at Los Alamos, that if intelligent life is common in the galaxy, we should have seen some evidence of it by now. Given the age of the galaxy, roughly 13 billion years, even a civilization that developed technology just a few 100 million years before us would have had time to spread across the entire galaxy. Where is everybody? The answers people have proposed to that question range from the beautiful to the terrifying. Maybe intelligent life is rare after all, and we are a vanishingly unlikely accident. Maybe civilizations reach a certain level of technological sophistication and then regularly destroy themselves through war, through climate collapse, through the particular self-defeating genius that seems baked into intelligence. Maybe they're here but they're not communicating because they've moved beyond communication technologies we can detect. Maybe the universe is full of civilizations talking, and we're just not smart enough yet to recognize the signal. Or maybe, and this is the thought I'll leave with you for a moment, the wow. Signal was the answer. One transmission. One moment of contact. And we missed it. But here's the question I actually want to ask you, because you're lying there in the dark and it's late, and this is the kind of moment when questions like this can land properly. What would it mean to you if the answer were yes? If tomorrow morning someone confirmed, beyond doubt, that the wow signal was a transmission from an intelligent civilization, That somewhere out there, around some star in the direction of Sagittarius, beings with minds and technology and the impulse to send their voice into the darkness had done exactly that, and we had heard them once for 72 seconds in 1977. What would that actually feel like? Would it be comforting? To know that the universe hadn't made minds just once, that consciousness was a thing the cosmos did regularly, that intelligence was part of the furniture of reality? That somewhere, in all that enormous dark, someone else was looking up at the stars and wondering? Or would it be terrifying? The Fermi paradox has a darker face, sometimes called the dark forest hypothesis. The idea that civilizations capable of contact are also, potentially, capable of harm, and that silence is not absence but caution. That everyone is hiding. That contact is dangerous. Or would it just be sad? In a particular way. The way it's sad to receive a letter from someone very far away who sent it so long ago they might already be gone. We heard something once. We couldn't answer in time. The universe is so large that even a response sent at the speed of light might take thousands of years to arrive. We are not neighbors. We are notes left under doors in empty houses. And what if the answer is no? What if we are alone? Not just in our galaxy, but in the observable universe. The only minds, the only eyes, the only voices? What would that mean? Some people find that thought exhilarating. We are the universe becoming aware of itself, the only self-awareness in 2 trillion galaxies, the cosmos's one experiment in consciousness looking around and calling itself alive. There's something magnificent in that version of the story. But tonight, lying there, I suspect the honest answer for most of us is that we are alone is the lonelier of the 2 possibilities. That we would rather, almost regardless of the implications, that there be someone else out there. That the wow signal was a hello rather than a coincidence. That we are not the universe's only attempt at wondering. I don't know the answer. Nobody does. The sky isn't telling us, not yet. But the question, the full weight of it, the strange intimacy of lying here on a planet surrounded by the void and asking whether any of it contains someone who might, if the frequencies aligned, hear us back, that question feels worth holding for a moment before sleep. Now I have to tell you something that will make you feel things. It is not a comfortable thing to tell, but it is part of the story, and the story deserves to be told completely. In 1997, Big Ear was demolished. It wasn't decommissioned. It wasn't repurposed. It wasn't preserved or turned into a museum or handed to another institution that might have used it. The radio telescope that had spent 30 years listening to the sky, that had produced the most extraordinary signal in the history of SETI, the one thing that 50 years of searching has not been able to match, was physically demolished, and the land was converted into a golf course. A golf course. I want to let that land for a moment. The instrument that captured the wow signal. The concrete and wire and careful design of a machine built to answer one of the largest questions humanity has ever asked. Torn down, so that people could walk around on flat grass and hit small balls with metal sticks. The land on which the Perkins Observatory and the Big Ear facility stood had originally been donated to Ohio State University with the understanding that it would be used for scientific purposes. The donor's intent was not ambiguous. This was land given to science. Ohio State University eventually decided that science was not the highest and best use, and sold it to a developer. The developer had plans. The plans involved fairways. Jerry Emmon protested. Other scientists protested. The people who had given their evenings and their expertise to the Big Ear Project, who had done real, careful, important work over decades for not very much reward, stood up and said this was wrong. And the university's decision stood. And the machines came. And by 1998, the telescope was gone. There is a particular flavor of human absurdity in this. We are a species that has the impulse to look at the stars, to build instruments of astonishing precision and sensitivity to listen for other minds across unimaginable distances, to dedicate years of careful, patient, unglamorous work to a question that might never be answered. We have that impulse. It's real. It's one of the things I find most admirable about us. We also build golf courses on the sites of the instruments we built to do all of that. We contain multitudes, as the poet said. Some of those multitudes are looking at the stars. Some of those multitudes are calculating tee to green yardages. Occasionally they come into direct conflict, and the golf course wins, and the universe's best ear in Ohio goes silent. There's a dark comedy to it that I suspect the cosmos, if it has a sense of humor, appreciates. We spent 40 years asking, desperately, whether anyone was trying to reach us. We received one possible answer, and then we demolished the receiver and built a place to golf. The coordinates where Big Ear once stood are now part of a residential and golf development. You can look it up on a map. The exact spot where those antennas once stood, pointing at the sky with such patient hope, is somewhere between the third and fourth holes, depending on which source you read. The sky above it is exactly as it was. The stars in the direction of Sagittarius are exactly where they were. The frequency is there, uncaptured, because the ear that was listening is gone. If something is still broadcasting from wherever the wow signal originated, we would not hear it from that spot. We built a golf course over our best ear, and we play our rounds, and the sky continues, indifferent and full. There is something deeply human about that too. So, here we are. Let your body settle. Let the day release its grip on your shoulders. You've been thinking about big things tonight, and that's all right. Thinking about big things in the dark is one of the better uses of the hours before sleep. It's what the dark is for, really. Come back with me to Ohio. August 15th, 1977. It's nighttime there too, and cooler than it is now, and the corn is tall in the fields, and somewhere on the grounds of Ohio State University a machine is pointing at the sky. Not because anyone expected anything. Not because tonight seemed particularly special. Just because it was pointing at the sky, as it had been for years, as it would continue to be, patient and unremarkable and aimed at the stars with the quiet faith of a question that doesn't require an answer to be worth asking. And for 72 seconds, something passed through. And it was extraordinary. And then it was gone. And the telescope kept pointing through the night and into the morning and for years after, and the silence came back, as silence always does, and it never broke that way again. The telescope is gone now. The fanfold paper printout, the original one with the red circle and the word wow in the margin, exists somewhere in an archive, behind glass probably, handled carefully by people who know what it is and what it represents. One extraordinary moment, preserved on paper, in the handwriting of a quiet man who told the truth about what he found and what he didn't know and kept telling it until the end. Jerry Emin is gone too. He passed away in 2023 after a life spent teaching and thinking and being careful with language about the thing he had found, and he went without knowing the answer, and the answer remains unknown, and there is something quietly right about that, that the mystery outlasted the man who found it, that the question is larger than any single person's ability to resolve it, that some things deserve to remain open longer than a single human lifetime. What he left behind is the word itself. That one beautiful, unguarded, honest word in the margin. But not a conclusion, not a claim. Just the sound a person makes when something unexpected walks into their life and they haven't had time yet to be careful about it. Just wonder, undisguised, for one moment, before the scientific caution came back and he put the pen down and started asking the harder questions. Maybe it was nothing. Maybe the universe has a way of producing extraordinary coincidences that look, briefly, like meaning and the wow. Signal was one of those, a natural phenomenon we don't yet understand, or terrestrial interference that behaved strangely, or something so mundane that if we knew the answer we'd feel slightly embarrassed about how much we'd thought about it. Maybe it was everything. Maybe somewhere in the direction of Sagittarius, around a star that's been burning for longer than our sun, there is a civilization that once sent its voice into the dark, not because they expected it to reach anyone, but because the alternative was silence, and silence felt, to them as it feels to us, like giving up. Maybe the signal is still going. Maybe they sent others. Maybe they've been listening for a reply that hasn't.